Welcome to this DaVinci Resolve Fusion node breakdown. Today's node is the camera shake node. So finishing up with our particle system nodes and everything, I realized I kind of skipped over some pretty basic transform nodes in Fusion. So for like the next week, we're going to be covering some of these basic nodes, and they might be a little boring, but just so you know, they're extremely important and very much used in almost every project you do. So they'll be short, simple, kind of boring, but we gotta cover them. So the camera shake node. So let's go ahead and add a camera shake, and you're gonna see multiple versions of it. One, because I've got plugins with camera shake on it, but the two main camera shakes within Fusion are the camera shake with the CSHK, or it might just say CSH, but it's the same one. And you've got a camera shake that doesn't have anything behind it. The one with the CSHK behind it is the actual Fusion node, and the camera shake one is a DaVinci Resolve plugin that just works in Fusion. So since we're going over actual Fusion nodes, we're going to use the camera shake with the CSHK behind it. So double click that. And the reason you might want to use a camera shake is in our footage here, it's nice and stabilized. You can tell they shot it on a gimbal, and it's nice and smooth. But your client might say, hey, I want to show a little energy and a little action in the shot, so you're going to have to add camera shake. And that's exactly what this node does. So let's go ahead and add it in the camera shake. I mean, in the our media. And you can see it's added a crazy shake to our footage. And up here you have your X and Y deviation, and all this is doing is deviating on the X axis. So if I crank it, it's going crazy on the X axis, and on the Y, if I go up, it's going crazy on the Y, and I can bring it down a little bit. Your rotation deviation is just how much that footage is actually rotating. The camera is rotating. If I crank it, you can see it's rotating on its center. If I bring this down, it's no longer rotating. Your randomness is how random these numbers are going to be. So it's just going to give you a random number up and down. Your overall strength is how strong your overall shake is occurring. So if I drop it down, not at all. If I bring it up, a little more. Your speed is how fast that is occurring. So if I crank it up, how fast it's moving around. If I crank it down, it's barely moving at all. And what I really like to do when I'm trying to hone in camera shake on footage is kind of look how the camera would really be moving. And obviously this cameraman's running behind her, so we can assume he's kind of in step with her, keeping up. So we can just watch her foot fall and see how her camera shake is going up and down. So let's crank this Y deviation a little more, and let's hone that speed in to the speed of her steps. So maybe something kind of like that. So we've got our footage going up and down, and if I shut it off, you can see the difference between our smooth footage our other footage with just a little bit of camera movement. And if you need more, you can up it. If not, we can drop it down. And that looks about good. So just a little camera movement to give it a little energy. So for these next ones, I'm going to zoom in so we can see what's happening with our image here. Now right here, your frequency methods determine the overall shape of the actual shake. So a sine is going to be kind of a nice smooth shake, or on your frequency method, whereas a rectified sine is going to give you a little more jittery camera movement, and the square wave is going to be a little more mechanical, like a mechanical wave. So we're going to leave that on sine. Now your filter methods determine how the rescaling of the pixels surrounding all the other pixels are going to look. So you're going to have a little more realistic stuff, but honestly, depending on your footage, you're really not going to notice a difference of what's going on. So the default of linear is pretty good. It's simple and it produces pretty fast results. Your quickest method is going to be nearest neighbor. And this is just how it's resampling these pixels as it's moving your image around. And we have box, which is a fairly simple interpolation resize of the image. Your linear, which is the default, uses basically the simplest filter. Quadratic, this filter produces kind of nominal results, and it offers a really good compromise between speed and quality. And you really don't notice anything. Sometimes when you zoom in, you're going to see some of your pixels shift when you change these filter methods. So basically whatever method works the best and looks the best on your footage as you cycle through is the one you're going to use. But you've got cubic, which produces kind of continuous tone images, and the one problem with cubic is sometimes it makes your fine details get a little blurry, and I really don't see any difference in our footage on these as I switch back and forth. The Catmull RAM is good for anything that you need to like resize down, like say you're shrinking your footage down and applying all this stuff. This is a good one. It'll maintain your pixel detail pretty good. Gaussian is pretty similar to the cubic. You've got Mitchell. Mitchell is about the same as the Catmull RAM, and it produces a little better results with fine details, but it's going to be a little slower than the Catmull RAM. The Lanczos method is similar to the Mitchell and the Catmull RAM also. It's just going to be a little cleaner, but it's going to be slower if it's got to do a lot of processing. And then your Sync and Pixel. Now, these two are kind of the same, and the problem with these is sometimes when you have a lot of detail in it, it's going to give you these weird like rings kind of ringing out on your pixels. And both the Sync and the Pixel have additional window methoding, and this is just basically how it's sampling those pixels around each other, and they're all pretty much the same. It just depends on how it's tapering down those pixels when it's bringing in stuff. And your best bet is just to thumb through them and see if they make any difference if you're using these, and see which one's the best. So, and I'll be honest with you, I rarely ever use the Sync and Pixel because the other ones are pretty good and faster. Down here you have the ability to invert your transform. So right now you can see it's moving, but it's inverted. But what this actually allows you to do, I don't know why you would do it, but we'll do it anyway. If, say, you added camera shake to your footage and then down the line you had to take all that camera shake out, if we copy this, paste it down here, we've got all this crazy shake going on. But if I hit invert transform, it's taken out that transform of that shake, and now we're back to our original footage. So I don't know, in case you ever need to add a shake and undo your shake, there you go. For your flatten transform up here, all this does is if you have other nodes, like surrounding nodes, and this camera shake is kind of affecting nodes coming down the line, if you hit flatten transform, it's going to make sure any of this movement data isn't pushed down the stream. That's all that does. So, and then up here we have the ability to input a mask. So if we wanted only certain areas of our image to be affected, now only certain areas are being affected. And you can move your mask around. And then up here, as far as your camera edges go, you've got the ability to change it to the canvas. So if we look at the bottom, you can see we're seeing our canvas in the background as our footage moves. We can make it wrap around, so the top is coming to the bottom and it's just wrapping around. We can duplicate it, so it gives you a little smoother edging around there. Or we can mirror it, so it gets mirrored. But honestly, your normal workflow, anytime you add a camera shake, would be to add a transform afterwards and just resize it to get rid of that stuff, to make sure your footage is staying in frame. But just in case, you've got the ability to change your edges. So that is the camera shake node. I will see you in the next node breakdown.